Hello guys, this is your host Lucas and you are watching a new episode of the Numberverse. Solve for all real numbers x and y such that 16 to the power of x squared plus y, plus 16 to the power of x plus y squared is equal to 1. Vedantu Math shared this problem and claimed only 1% of students could solve it, and it's from one of the hardest exams in India. Pause the video if you'd like to give this problem a try, and when you're ready keep watching to learn how to solve this. So this is an extremely challenging problem. So first thing to notice is for real numbers x and y, 16 to the power of some real number will always be a positive number, so these two terms we're adding will be greater than 0, therefore we can apply the arithmetic mean geometric mean inequality, also known as the AMGM inequality, for non-negative numbers a and b. We always have the arithmetic mean a plus b all over 2. Which is greater than or equal to the geometric mean, which is the square root of the product of a and b. Furthermore, equality holds if and only if a is equal to b. It is oftentimes useful to rewrite this inequality by multiplying both sides by 2, so we have the sum of a and b is greater than or equal to 2 times the square root of the product of a and b. So let's apply the AMGM inequality to this problem. We are summing two terms which we know are greater than 0. By the AMGM inequality, this will be greater than or equal to 2 times the square root of their product. We're now going to rewrite this expression in many ways, but we will keep this greater than or equal to sign so that we remember that 1 is greater than or equal to the result. So first we'll rewrite the square root as raising to the power of 0.5, then 16 is equal to 4 squared. We have 4 squared being raised to some power, so we can simplify this by taking the product. Now this 2 and this 0.5 will cancel out in each of these terms. From here we will further simplify the exponents. We will group the x terms in one exponent, and the y terms in the other, so we have 4 to the power of x squared plus x multiplied by 4 to the power of y plus y squared, then 2 is equal to 4 to the power of 0.5, and 0.5 is equal to 0.25 plus 0.25, so we will put 4 to the power of 0.25 in each of these exponents in the product. So this is equal to 4 to the power of x squared plus x plus 0.25 multiplied by 4 to the power of y plus y squared plus 0.25. We will factor each of these exponents, the first factors to be x plus 0.5 the quantity squared, and the second is y plus 0.5 the quantity squared. Now what's interesting about these exponents? Well, each is a square term. So each exponent will be greater than or equal to 0. For raised to a power that's greater than or equal to 0 will be greater than or equal to 1, so this product will be greater than or equal to 1, but now we've shown something interesting. We've shown that 1 is equal to something and it's greater than or equal to all these expressions, and finally 1 is greater than or equal to 1, so we've now squeezed all of these expressions between 1. Now of course 1 is equal to 1. That means each of these inequalities must actually be an equality, so all of these are equal to 1. In particular, let's look at the last two expressions. We must have 1 is equal to the product 4 raised to the power of x plus 0.5 squared and 4 raised to the power of y plus 0.5 squared, but remember each of these exponents is greater than or equal to 0. Because we have a square term 4 raised to 0 is equal to 1, so it must be the case that each of these is equal to 4 to the power of 0, so that means 0 is equal to each exponent, 0 is equal to the square of x plus 0.5, and 0 is equal to the square of y plus 0.5. We can solve these equations to get that, x is equal to y is equal to negative 0.5, and that's the answer. I hope you liked this video. Thanks for watching. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more such content. If you have any interesting brain teasers or puzzles, you can share it to us through Instagram. Thanks for your support.